Okay. So we have that. We have that. Okay. We have our number. We have our tens and our hundreds. That's what we're going to do. So we have our tens. We have 5. The top bead touches the horizontal bar. This is considered counted. So then we have 8. 5, 6, 7, 8. We have 8. 5 plus 3 is 8. So we have these 2 columns. It's a 2-digit number. These 2 columns are being counted. These ones that are not touching the horizontal bar are not being counted. Only these 2 are being counted. Hello, Helen. Hello, Helen. How's it going? How's it going? How was school? I hope it was okay. Yeah? Good evening. Good evening. All right. So we're going to look. Do you remember what number this is, Helen? So we have our top bead. School hasn't started yet. Really? When does your school start? When does school start for you? My kids are already in school. They're in school. They've been in school this is their second week. Hello, Polino. Thank you. Yes, you're right. It is 58. Well done. It is late. Yes, it is very late. And you're still here. You should be in bed. You should be sleeping. Actually, you should be sleeping, not watching. It starts on the 26th. Oh, okay. So do you have any movies or TV shows that you're hoping to watch before the school starts? Thank you, Ali. Yes, it was 58. Well done. Thank you. And then we have our next number. We have our tens and we have our ones. Notice that when the beads are touching this horizontal bar, it's being counted. Oh, I don't like TV shows. Oh, that's sad. Thank you, Vic. It is 90. It is 2. So, you can't see that. It is 92. So we have 90 and then 2. Do you watch movies? I like movies. I would binge movies. I think my kid's going to start binging Pirates of the Caribbean. So we have our next number. We have our tens and we have our ones. We have our tens and we have our ones. You don't watch movies either? Or what do? You doom scroll, don't you? That's going to rot your brain. That's going to rot your brain. What number do we think this is? Well, thank you, Ali, unless you watch me and then this is not rotting your brain. Thank you, Vic. Thank you, Ali. Thank you, Helen. It is 14. Well done, well done, well done. So we have our next number. We have our tens and our ones. I'm kidding. I'm just kidding. You don't need to watch me. No, it is not 55, Helen. It is not, because if you look, you're going to see what? There are 4 beads at the bottom. 1, 2, 3, 4. Another 4. 1, 2, 3, 4. 55 looks like this. That's what 55 looks like. So we have 55, but this was actually 44. Thank you, Dancer. Thank you, Vic. Thank you, Ali. Thank you. Bye, Felipe. Aw. 2820. Thank you, Helen. Yes. What's happening here? What's happening here? Hello, hello, hello. Oh. We're having a party down here, Brooklyn! Brooklyn! I don't know if you're from Brooklyn, New York, or if that's your name. So, what is our next number? We have our tens and we have our ones. We have our tens and we have our ones. When the beads are touching this horizontal bar, this is considered counted. So we have our tens and we have our ones. Thank you, Helen. Thank you, Vic. It is 66. That's my name. Oh, okay. Brooklyn! Oh, that's cool. That's a good name. I like that name. So we have our tens and our ones. We have our 5 and then 6. 5 plus 1 is 6. 5 plus 1 is 6. Thank you, Dancer. So we have 66. That's what that looks like. So we have 66. That's what that is. And then our next number here. Thank you, Ali. Yes. So have our next number. We have our tens and we have our ones. This is really easy, isn't it? Maybe I should have gotten for the 3-digit number. So thank you, everybody. Thank you. Thank you. Thank you, Dancer. Hello. Thank you, Vic. Well done, well done. And so, what do we have? Thank you, Ali. We have 35. We have 35. We have 3. 1, 2, 3. Anytime the beads are touching the horizontal bar, it is considered counted. So we have 3 on the tens and then 5 on the ones. The top bead, the blue bead, will always be a value of 5, no matter what. So if I did this would be 55. If I did this, it would be 555. If I did this, it would be 5,555. This is 55,555, and then here, it would be 55,000, no, 55,555 point. We have to remember our decimal place, right? So we have a 5 and a 5. Welcome, everybody. Welcome. Please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
Thank you so much for the rose. 55 burgers, 55 fries. Is that a song, Will? I don't know. I don't know that song, but I'm going to have to look it up if that was the case. Yes, thank you, Helen. Yes, it is 55,555.55. If it's a song, I'm going to have to look it up. It's from, I think you should leave on Netflix. Oh, really? Hello, Jello. Hello, Jello. So our next hello, little late for everything. Actually, you're early this time. You're actually early this time. So what's our next number? We have our 10s and we have our 1s. It's a pay it forward joke. I wouldn't know. Okay, so yes, it is 50. It is 7. Remember that the top beat is a value of 5. When the top beat is touching this horizontal bar, it is considered counted. So we have 50. The top beat is 5. We have the top beat over here. So we have the two bottom beats. So we know that 5 plus 2 is equal to 7. So we have 57. Thank you, Helen. Thank you, Jay. Thank you, Jay. Thank you, Vic. Yes. Thank you, Ali. And then we have 57. That's what 57 looks like. And then we have this. Hey, Jello, when does school start for you? So we have our next number, we have our 10s, and we have our 1s. What number do we think that is? 29. Thank you, Dancer. Thank you, Ali. Thank you, Jay. Yes. Well done. Easy, right? Simple to use, easy to understand. Thank you, everybody. Thank you. It is 29. 29 looks like that. And then we have our next number. Oh, this one's too easy. You're doing God's work. Thank you, Will. I appreciate that. I'm happy. Thank you. I'm also here to bring out new jokes. I think I've got new jokes. Whoa! You went like 50 to 200 in views in 1 minute. I mean it. Oh, really? Oh, thank you. Yeah, I'm trying to entertain as well.
This is the way.
This is the way. This is the way.
Thank you, Helen, for letting me know. What number? We don't know what number this is. So if I did this, what number do we think this is? When we do it, it is a reset. Thank you, Vanny Pause. And thank you, Jay, for the rose. Thank you so much. Thank you. Yes, right? Easy. That was too easy. Simple to use, easy to understand. Yes, Jay, you're absolutely right. You are absolutely right. Whoa. Okay, so we have our next number. Thank you so much. Thank you, Mary Jane. Thank you so much. What we're doing is we're visualizing our numbers. When we visualize our numbers, we will be able to add, subtract, multiply, and divide. That's what we can do. But the first thing we need to do is understand how to add, subtract, read the abacus. I don't understand. I'm having fun. Okay, Ruby, guess what? We're going to do a little review. Thank you, Helen. So we have 48, which Helen mentioned. You're right, Dancer. It is 47. So we have 4, 1, 2, 3, 4. Ruby, are you still with me? We're going to have the 5 and 6 and 7. So we have 5 plus 2 is equal to 7. We have the top bead is a value of 5. The two beads to the bottom beads is a value of 2. So we have 1, we have 2. 1, 2. So that's how we get 4. 1, 2, 3, 4. So the question, the answer is, thank you, Daniel. Thank you so much. It is 47. We have 4 in the 10s column and then 7 in the 1s column. Thank you so much. Thank you. Yes. So we have our next number. What number do we think that is? Thank you so much, Dub. Thank you. Thank you guys so much for the gifts. Hello. Good evening. Hello, everybody. For those of you that are here, please keep your mind open for something new.
Now, open your mind to me, please. Open your mind.
Thank you, Jay. It is 60. It is 2. We have 60, 5, 6. 5 plus 1 is 6. And then we have 2. Well done. Thank you, Helen. Thank you. Good morning. Hi. Good morning, Robert. Yes. Thank you. Such a wholesome stream until I see trolls. And then I get a little snappy. All right, what's our next number? And this is going to be our last number. What number is this? This is our last number. What number do we think this is? Hello, everybody. Thank you so much for joining. Thank you so much for joining. It is not 68. It is 63. Thank you, Dragon Mama. Thank you, Dragon Mama. That's a really good screen name. I do like that. Thank you, Helen. Thank you, Jay. Thank you, Allie. Yes, it is 60. It is 3. When we're looking, we have 60. When the beads are touching the horizontal bar, this is what's being counted. We have 2 columns that are touching the horizontal bar. That means we're doing 2 digits. Just as we have here. Thank you for checking in, Doug. For those of you that are interested, please check in the orange heart me right around where my forehead is. Hopefully my forehead's big enough for you to touch it. So we have 6. 5 plus 1 is 6. We have 3. 1, 2, 3. We have the ones column. Okay, see you later. Have a good night, Helen. Have a good night. And I'll see you in my next live. Thank you so much for dropping by and talking with me. Okay, so what are we doing is we're going to do 63. We have the 2 beads here. 5, 6. 5 plus 1 is 6. And 3. 1, 2, 3. So we have our tens, and our ones. That's what we're doing. So when we look, we have our place value. Every column is a place value. We have our ones, tens, hundreds, thousands, and 10,000s. See you later, Helen. After the ones, we have our decimal place. The decimal sits between our ones and our tenths, right? So what does that mean is we have our decimals. This is our tenths, and then this is our hundredths. I've been putting off how to learn. I've always put off learning how to read the Abacus. You really wanted to read it? Well, I'm so happy I showed up, I guess. I don't know. Thank you, DJ. Thank you so much for checking in. Hello. Please, for those of you that just joined, please keep your mind open for something different.
Now open your mind to me, please. Open your mind.
Okay, so what are we doing here? Well, what we're going to do is we're going to continue to understand how to read the abacus. So if I actually did this would be 99,999.99. That's what that would be. Right? And so if I wanted to do this, we would be 55,000, and there's a comma here. Notice this comma has this marker. This marker is my thousands. Why? Because this one is my ones place, just like a Pokemon.
Okay, Charizard, I choose you!
So if I choose this one as my ones place, then this one will be naturally my thousands place, just like a comma. So my ones, so I have 55,555 point. Remember, there's a decimal, sits between the ones and the tenths, and then we have our hundreds and our thousands. So then you might be wondering, well, what happens if I did this number? Well, this number would be 3,456. Notice I have 3, 1, 2, 3. The top beat is not touching the reckoning bar. The top beat is not touching the horizontal bar, so that's not counted. If I touched it like this, if it came down and it was touching this horizontal bar, this would be 8. But if it's not, then it's 3. It's the same thing with this one. This is 4, 1, 2, 3, 4, and then I have this 5. So 5 plus the 5 is 9, and then we have 5. Right? This bottom beads are not touching the reckoning bar, so that's why they're not counted. There's only a 5 here. And then what are we going to do is we're going to have 6. We have 1 bead on top and 1 bead on bottom, and then we have 6. Cool in Dune. I'm doing homework right now. This is helping so much. Really? I don't know how much this is helping. I'm just rambling. That's all I'm doing. I just ramble numbers. Rambling numbers. I like to ramble numbers. I enjoy talking about the abacus. So what does this mean? This is a counting tool. All we're doing right here is visualizing our numbers. Well, guess what? What happens if I choose this to be my ones place? Then I would move everything over like this, just like a Pokemon.
Pokemon, I choose you!
And then I could do 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Well, after that, notice now I can actually make a really small number. So if I line it up, this will be my ones. Ones, 0.00001. So that's what that would look like. So now I have a really, really small number. So let's do a little review. Thank you everybody for joining. Thank you everybody for joining. It would be like Roman numerals. So I don't know if you remember your Roman numerals, but we had the 1. This is what 1 would look like. If we have 2, right? 1, 2, 1, 2. If we have 3, 1, 2, 3, we would have 3. 1, 2, 3. If we have 4, well, we don't do a minus. What we do is 4. 1, 2, 3, 4. But then we have 5. If you look, 5 is a V. This V would be very similar to the very top bead. That's what that would look like. So this is 5. Thank you, everybody. Thank you, everybody. For those of you that are interested, please check in or go ahead and tap out the screen so we can share my live. Thank you for the follow. So thank you so much for tapping. And so we have our 6. Notice there's a 1, a 5, and a 6. So 5 plus 1 is 6. Thank you so much for sharing. Thank you so much for following. Right? And then we have 7. 5, 6, 7. We have 5, 6, and then 7. So that's how we read the abacus. So we have 8, 5, 6, 7, 8. We have 5, 6, 7, and then there's 8. And then 9. Exactly what 9 is. 5 plus 4 is equal to 9. Are we ready? Okay, so what we're going to do is, well, what's 10? Oh, I almost forgot. 10 is a 1 and a 0. So what did we do? We zeroed out, we reset our 1 column, and then we added the 1 here. So now we have 10, and now it's a 2-digit number, just like how we write 10. So when we're looking, we have 11, 12, 13, 14, 15, 16, 17, 18, 19, and then 20. 20 is a 2 and a 0. Does that make sense? So how are we doing? Make sense? What we're going to do is we're going to understand how to add, subtract, multiply, and divide. So, oh my God, I think I understand it now. I've been, really? Since this morning? That is hilarious. You guys are the best. That's the best. That's the best. That's so awesome. I totally love it. That's it. Really, it really warms my heart. It does. It really warms my heart. How do you know what column when the beads go up? I have a marker. There's a marker right here. I don't know if you can see that. There's a marker right here. This marker tells me the ones place. That's what I would do. So when the beads are down, yes, exactly. So when we're doing it, valve, alley, right? All the beads, all the top beads, whatever's here above the line is a value of 5. That's what we're doing. Thank you, Sailor. Ha, that's great. I don't know how to use it, but it looks awesome. Okay, good. Thank you. Very human. I've been watching docudramas and I said I want to learn. What happens when one day we have no phones? What happens when we have no phones? Then you won't know how to learn. You won't have the abacus to learn because you don't know it right now. Why? Wait, why is the top row 5? It just is. Random user. I don't know. Random user. No, it's just the way it is. That's all it is, right? So just like how, you know what? It'd be like the question, why is this 5 cents? You know what I mean? It's just the way it is. Why is this a penny? Or why is this a penny? It's just the way it is. Why is this 10 cents? I don't know. You know what I mean? So when we're looking, we have our top bead. The top bead is like a value of 5. That's what it is. Right? And then when we're looking, we want to add the 5. When we have 5, we add the 1. That's now 6. We have another 1. We have 7. We have another 1. This is 8. Right? 5, 6, 7, 8. We have another 1. This is now 9. 5, 6, 7, 8, 9. Thank you. Taoist. It's just, yeah, it is. Yes. Oh, here, even better. Oh, where is it? Oh my God, I've lost it. More than you know. Yes. Good morning. Open your mind and welcome. Here it is.
This is the way.
This is the way. This is the way.
It is the way. This is the way. Last night you're very good visual educator. Oh, thank you so much. Thank you very much, BG. Oh, I love the Bee Gees. Okay, so thank you, random user. I don't know. So one would be engaging. Thank you so much for checking in. One would be only engaging the green bead in theory. Not necessarily. Why? Because if we're looking, this is one that we're engaging. We're removing it. We're subtracting it. Does that make sense, Ali? So when we're looking, right, this would be a 1 and we're engaging with the 1 bead. Don't look at the colors. Look at just the beads. When we have the beads, we want to just pay attention to the positions of the beads. Each column goes up to 9. Yes, Doug. Right? 999, 999, This is a 13 column abacus for any of you that are interested. I do sell this available in my shop. So, and the neighbor, it becomes 10. So when we do 9 here, right, our neighbor would be 10, just like a 1 and a 0. Let me see if I can. Just as how we write our numbers, we have 10. 10 is 1 and a 0. And then we have 11. 11 is what? 1 and 1. 12 is 1 and 2. That's all we're doing. That's all it is. Okay, good. Okay, good. Good, Ali, right? Makes sense? So when we do 13, 14, and then 15, and then 16, 17, 18, 19, and then 20. 20, 30, 40, 50, that's 50, right? We want to make sure all the beads are not touching. We're only doing this, 50, because this is a 5 and a 0. We have 60, 70, 80, 90, and then 100, right? It's the same as a soroban. This one specifically is a soroban. I can't leave, Madeline. You guys are awesome. You guys are so awesome. It is, this one specifically is a soroban, Tanu. This one is not a soroban. This is a Chinese abacus. A Japanese abacus is a soroban. It has 1 bead on top, 4 beads on the bottom. The Chinese abacus is 5 beads on the bottom and 2 beads on top. And they work similar, but they're a little bit different. When we're looking at it, they're in the Chinese abacus, they count up. In the Japanese abacus, we use formulas. And all of the books that I have is all soroban specific. So what I want to do is I want to abacify the world. Everybody, thank you so much for joining.
Welcome to the real world.
So for real, this content has me in a chokehold. Would this help children starting math? Yes. Yes, it would. Do you know why? Because it would be as if we were replacing our bricks. Have you seen these bricks being used? No, not a problem. You let me know if you have any questions about the abacus. Even if you want to, well, you know what we're going to do is we're going to count it. So we can count 1, 2, 3, 4, 5. The top bead is a value, no, sorry. Because we have 5 here, we're going to exchange this. We're going to do a trade. So we have 5 here. We're going to make this 5. That's what this is. So this is now 5. We have 6. 5 plus 1 is 6. 7. 5 plus 2 is 7. 8. 5 plus 3 is 8. 9. 5 plus 4 is 9. And then 10, right? 1, 2, 3, 4, 5. This is 10. Because we have 10, we're going to trade that in. So now this is 10. Now guess what? We're going to trade this in and we make this 10. So now we have 10. Just like we have this, right? We have 1, 2, 3, 4, 5, right? 6, 7, 8, 9, and then 10. That's what that would be. Okay, so I haven't seen those bricks for in your bring back memory. Yes, I want to see the bricks too. So okay, hold on. So you make very good sense. Thank you, Virgo. Chinese abacus makes way more sense to me. That's cool too. You can, but I don't teach the Chinese abacus. I teach the Japanese abacus because in Japanese abacus we use formulas. Chinese abacus does not use formulas. And what they do is they count up. So let's do it with the bricks. If I have 1, then I have 1. If I have 2, that would be 2. If I have 3, this would be 3. If I have 4, that's 4. 1, 2, 3, 4. 1, 2, 3, 4. 5 is that. I got to put it all in. This is my 5. This is my package. This is all stuck together. I made it stuck. This is 5. So we have 6. That would be 6. We have 7. That would be 7. This is 8. This is 8. right? 5 plus 3 is 8, and then this is 9. And that's 9. There you go. Abacus is the winner. Winner, winner, chicken dinner. Okay, so the colorful abacus. The colorful abacus is nice because it's pretty to look at and it's easier to understand. Because the one thing is you're also looking through a video, so it's a little bit harder to see. So what are we going to do now is we're going to understand how to move the beads. But wait, there's more. The reason why we're understanding how to move the beads is because we can do adding, subtracting, multiplying, and dividing. So the Chinese abacus, yes, is 2 beads on top and 5 beads on the bottom. Yes, the 2 top beads are a value of 5. You're absolutely right. Just like how the Japanese abacus, the top bead is a value of 5. So when we're looking, that's what 5 would look like. Excuse me. 5 and then 10. This would be 50, 60, right? Because this is a 10, this would be 60. And then this would be 110, right? And then this would be 1,110. Whew, that one's a tough one. Yeah, why? Because this is 10, you got to trade it in to do that. This is 10, you got to trade it, 100, trade that in to do that. So then trade this in to do this. That's why I'd have to think about it. They do more trading than they read it. They do more trading. Yeah. So, hello, son. How's it going? How do you do multiplying and dividing with the abacus? Oh, that makes sense. But I didn't know if the row of the beads are the ones and the yeah, exactly. So if I did this would be tens, and it's a little bit off for me. I need to make sure that I trade it in to make this a tens. And then if this comes here, then I have to make sure that I trade it in to make this. So then it'd be easier for me to read. That's why it takes a little bit. But whatever. Here we go. No judging. Hello. I like the colorful ones better. Mary Jane, what did you miss? I'm not sure what you missed. Hello, everybody. Hello. Thank you so much for joining. My name is Lynette. I've been teaching Abacus for about 20 years. And I know how to count really well from 0 to 9. Please keep your mind open for something new.
Now open your mind to me, please. Open your mind.
You know, interesting, Doug. Chinese abacus actually started in the 1st or 2nd century. And then in the 1600s is when the Japanese came around and said, we're going to make it easier and more efficient. So there's actually abacus competitions for this specific abacus. That's how much it's been around. And apparently, I heard from somebody that it's all over Africa. And I'm like, that's really awesome. I know there's a few African teachers that follow me, and they have like a full class. And so I'm here to abacify the matrix.
Welcome to the real world.
Audrey, there you are. Anybody's interested in algebra? I may not have been born in abacus. I'm sorry. I may not have been born in Japan, but I love Japan and I love learning. Oh, good. Thank you. Japan really is the best. Yeah, they make everything so efficient. Okay. And, but interesting, Koreans are also just as efficient. So in Korea also uses abacus as well. They use, I believe, the soroban. I believe they use the Japanese abacus. So this is a soroban. Hello. Japan, I'm visually, and Chinese, one loses me. Ancestors are so smart. If it was up to me, they'd be banging rocks. We have a preschool book. Why do I have a preschool book? I have a preschool book because I wanted to start the kids young. One of the questions was, how early can we start the children? You can start as early as when they start learning how to count. And so thank you so much, Very Human, for the gifts. Thank you. And so when we're looking, we want to understand how to read the abacus. This is my my activity for the children to understand what numbers are. That's all we're doing. I'm trying to relate the numbers, the regular numbers that we have in average life, in ordinary world, and relate it to abacus. And so when we're looking, these are just activities to strengthen and to show the one-to-one that this is the way in the abacus, this is what it reads. And then I have like activities for them. This one goes from 0 to 9. I'm sorry, we go from 0 to 9, and I have more activities. They're broken up into like how to count forward. After counting forward, there's counting backwards. After counting backwards, it's like we talk about the relationship. So what comes on the number in between, and then after that we go what's the number surrounding, and these are all the activities I have. We have comparison and so forth. So then we're getting into the point where we need to understand how to add and subtract, and here we are. What we're going to do in Abacus World is we're going to focus in on the second number. When we focus in on the second number means what? This is the number that makes sense. I'm sorry. This is the number that we're going to look at. We're not going to focus on the... Is the coloring your handiwork? Yeah. Yes, it is. Yes, it is. Anyways, so what we're going to do is we're focused on the second number. We're not going to focus on the result. We do not focus on the result. What we're going to do is focus on the second number. Why? Because we're going to divorce the result and marry the process. Why? Because we need to know if we have enough beads. If we don't, then we have to figure something out. So the question is 7. So here's 7 on the abacus, 5, 6, 7, and then we want to add the 1. Can I add the 1? Yes, I can. I can add the 1. So I add the 1 and my final answer is 8. 5, 3 is 8. Hello. Oh, my dog is sleeping next to me every time I stop petting him. I love this video. Oh, thank you so much. Very, very human. Yes, thank you. Here comes the sun. Here comes... Oh, I had a song. I'd have to remember it again. Anyways. So then our next number is 2. We remember what we're doing is we're understanding how to add the 2. When we add the 2, right, if I have 7, I'm going to add these 2 beads. It doesn't matter which 2 beads. If I had 6, I want to add these 2 beads. The idea is to understand just to add the amount of beads. So when I want to add, if I have 5, I want to add 2, I want to add these 2 beads. So it doesn't matter which beads, it matters the quantity of beads. That was so wise. Divorce the result and marry the process. I've got a lot of quotes. Simple to use, easy to understand. Abacus is the gateway to complex math. So, abacus is life. We want to know about the journey. We don't want to know about the destination because everybody's destination is death. Just saying. Doesn't matter how you get there. That's everybody's destination. We don't want the destination. What we want to do is understand the process, right? We want to understand how we get there. And how we get there will always be very different. So when we're looking at the 3, we have 5 plus 3. Our final answer is 8. You can now supertize. When you supertize, what does that mean? What does that mean? That means that if you look at a number, you know what it is. You know that we have in our ones place, we have 8. We know that the top bead is 5. The 3 beads on the bottom is equal to the 3 beads at the bottom are 3. So 5 plus 3 is equal to 8. And then if you want, you could do the tally marks. You could do tally marks. That's perfectly fine. Thank you so much for the gift. Very human. Thank you so much. So for those of you that are interested, you could do the tally marks. That's perfectly fine. But guess what? In Abacus World, we can actually scale. What does that mean? Because we could say 50, 50 time, plus 30, 30 gives me 80. So when we're looking, we have 80. What do we have? We're representing our numbers. We're not representing the quantity. You could represent the quantity, but it's a little difficult because it's a lot to see. Our human brains cannot actually see more than 5 items. We would have to break it up and start counting it all out. So, does it matter where you start? Matter in space? Yes, it does. Yes, it does. It matters because there's my dot. This is my ones indicator, and that's a really good question. Thank you so much. I do appreciate that. Because you know why? Because now I know you're actively learning. So when we're looking, this dot is my ones indicator. This ones indicator tells me that that's where my ones will sit. So we have our 1, 2, 3, 4, 5. 6. 5 plus 1 is 6. 7. 5 plus 2 is 7. 8. 5 plus 3 is 8. And then 9. 5 plus 4 is 9. And then what's after 9? We reset the ones place, and then we carry to the tens. And then we can count again. 10, 20, 30, 40. Okay, why the ones place in the middle? Are the 2 places in the... Yes. Why is the 1 place in the middle? Random user?
This is the way.
This is the way. This is the way.
It's just that's just it. These 2 are the decimals. You're right. Yes, you're right. These 2 are the decimals. I think the Y kind of, I think it's the Y that's like, why is it the ones place? I don't know why. No, but you know what? Let's say we want to do this. Let's say we want to put this one as the ones, right? Thank you. Here comes the sun. We want it. Thank you for checking in. Hello, I am bored again. So if I want to make this one the ones, right? Notice there's two. This is a grouping. But if I choose, and then this would show me that this is my thousands if this is my ones, like a comma. But if I choose this one to be my ones, then I would do this, and it'd be the same. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. And then we would have, if you want, you could, all of this would be the decimal. It'd be 0.00001. Right? And so it'd be a very, very, very small number. Hello, I am bored again. Does that make sense? So when we're looking, yes, every column is a place value, but it's not set in stone. Because it's an abacus. I don't know how to there sounds like there's going to be a joke in there somewhere, but I can't figure it out right now. But so it doesn't matter which one of these dots will be your ones place. You just need to choose one. So it depends on what? It depends on how big your number is or how small your numbers is. Wow, can actually be useful for calculating moles in chemistry. I don't know, random user, because that is above my pay grade. That is way above me. Oh, good. Oh, good. It's not set in stone because they're beads. Yeah, there's something there, right, Salt? There's something there. It's not set in stone because something. I don't know what it is. There's a joke in there. I don't know. I feel like there's a joke in there somewhere. So when we add, we go to the horizontal bar. That's what we're adding. We're adding the 4. When we subtract, we go away from the horizontal bar. So you know how to add, we know how to subtract. We're going to take away the 1. When we take away the 1, we're going to have 6. We want to take away the 1. And so what we do is we move it away from the horizontal bar. We move it away, and that is it. I figured it's under the assumption of whole numbers. Yes, but decimals are not whole numbers, right? Decimals is I don't know what decimals are, like partial numbers. But yes, you're right. It is under the impression of whole numbers. And back in the day, they didn't have fractions, right? Only now, later math, like now math, we start doing fractions and all this and that. But I don't think they did fractions back in the day. Because if you really think about it, Abacus started before Christ. It started like 500 BC in Mesopotamia. And so when you're looking at it, I don't think they took a quarter of... I don't know if they did quarters in Mesopotamia. Decimals are real numbers, not whole numbers. Oh, okay. Yeah, I think the decimal only happened when we started doing the decimal system, and then they realized that they can do smaller numbers. Okay, so we have 2. When we have 3 on the abacus, I want to take away 2. Again, I'm taking away these 2 beads. That's all I'm doing. And it's the same thing with the 3 and the 4 and the 5. And we're going to do the 5, adding of the 5. So we have 3 on the abacus. I want to add the 5. Can we do it? Yes, we can. Yes, we can. We can add the 5. So my final answer is 8, right? And then the same thing with the 6. Or the 7. If I have 1 on the abacus, I want to add 7. 7 is 1 bead on top, that's 5, and then 2 beads on the bottom, that's 7. So we bring it together. Does that make sense? So my final answer is 8. What we're doing is we're representing our numbers. And if I have 2 on the abacus, I want to add 7. I do that. If I want to take away 7, I just push it apart like that. If I have 9 and I want to take away 6, I just push apart the 6. That's what I'm doing. So you have to pay attention to what you're pushing apart. You know how to add, you know how to subtract, because it's just the inverse movement of the beads. And then we have 8, and then we have 9. 8 is the same way. We have 1 on the abacus, we have 8. That's it. We take away the 8. Which is very interesting because we don't need to memorize how to make a 9. Why? What is a 9? Why are we doing that? I don't know why the kids are told to memorize how to make a 9. I don't know why the kids are told to memorize this, but in abacus we don't need to memorize it. Because, why? Well, if I have 1 on the abacus, can I add 8? Yeah, I can add 8. Look, 5, 6, 7, 8. Add the 8. There's no memorizing involved. So if I have a 2 on the abacus, I need to add 7. Oh, look, there's 2. So in mainstream, you have to do a lot of memorizing. But in abacus, we can actually visualize it, right? We can say 3, 1, 2, 3. I want to add the 6. So I add the 6. Again, we're not focusing on the result. What we're focusing on is, can you add it, right? Can you add the 6? Yes. So here we have 4. Oh, look, we have 4, and then we want to add the 5. We have the 5, and then we're done. I'm confused. Why are you confused? You're confused that you have to memorize the 9? You don't need to memorize the 9. That makes sense. You taught me in a few minutes how to use it. Yeah, it gets better. But wait, it gets better. I'm back trying to connect my laptop to my phone. Welcome back. I am bored again. Yeah. Why are you confused? Matter in space. These are not grams. Okay. We're going to continue on. Well, what happens? I'm learning. Yes. Thank you, Mary Jane. Is that an abacus? Chillin', you know. Yes, it is. Yes, it is. Thank you so much. It is an abacus. And then I have all these activities for the abacus. There you go. Okay, so what are we doing? What's going to happen? Well, what's going to happen is what happens when there's not enough beads. What does that mean? Well, if you notice, can we go over multiplication? Thank you, Giorgio. You have a great teacher vibe about you. I don't know, Salt. We can talk about multiplication, but I don't know how many people know. Okay, you know what? And subtracting. The subtracting? Oh, okay, hold on. So we have 9. When I want to take away 6, right? Remember what 6 is. 6 is 1 and a 1 bead on the bottom and 1 bead on top. So I have 9 and I want to take away 6. I have to do the same. But instead of doing the green one, I can do 1 bead here and 1 bead here, and that would be 6. I'm thinking about the multiplication, Salt. When we run out of beads, you move to the next column. She'll probably get to it later. Yeah, probably. I think a little bit later. What time is it now? It's about an hour and... Yeah, I try to get to it. I wish my math was this simple. Too many letters and too many symbols. Did that make sense? Matter in space? So when we're doing 7, let's say we have 9 on the abacus. I want to take away 7. Take away 7 is minus the 5 and the 2, and you push it apart. Yeah, I Am Bored Again has been around for a little bit. So is Here Comes the Sun Again. Thank you guys. Thank you so much for joining. Please keep your mind open for something different.
Now open your mind to me, please. Open your mind.
Okay, so matter in space, it makes sense. So matter, when we do 8, 5 plus 3 is 8, right? And I want to take away 7, I'm pushing these 2 beads. Does that make sense? So I can do it again. If I have 9 and I want to take away 8, I push these 2 beads. So it matters what? It matters the beads that you're touching. So it doesn't matter if it's 1 bead, 1 bead, 1 bead, or 1 bead. That doesn't matter, right? So every bead, this is not 1. The fact that it's just the one item, that's what we're doing. But it's different because it's in a column, right? But it has nothing to do with this is not 2, because this could be 2. Do you see that? Or this can be 2. Does that make sense, Matter? So don't focus that this is 1. Focus that these individual ones are 1s. Yeah, right? Just like how we have the pennies. Remember I brought out the pennies? When I brought out the pennies, this is 1. This is 2 cents, but this is not number 2, right? This is 3 cents, but this is not number 3, because this is not number 3 and this is not number 3. That's the same thing with the beads. This is not number 3. This orange one is not number 3. It's just there's 3 beads. That's all that is. Yeah, some people get mixed up on that. But when I tried to explain it, I think that's how I explain it. We're just looking at the 3 items. Right? And then this is 4, right? We have 4. All of this together is 4. Because we add the 4, we take away the 4. Add the 4, take away the 4. Yeah? All right. So, okay. So you might be wondering, well, what happens when there's not enough? We're going to start going into a concept. We're gonna see it. Okay, good. Yeah, sometimes that gets a little confusing. Thank you. Thank you so much for the tiny diny. I am bored again. So what are we going to do? We're going to understand this concept. 1 plus 4 is equal to 5. Why are we going to... I don't know. I feel like I talk to myself a lot. I got free books A&A. I got... Ooh! And now I have 100 books. Wow, really? I got two free books. Wow. We're learning how the beads work. Oh, are we learning how to... I'm sorry. Oh, are we learning how that bead thing works? Yes, we are learning how to use the abacus. My bestie is like, oh, hey, 200 for the year? That's a lot of books. That's a lot of reading. I don't think I've done 220 books. That's crazy. And it's already August. So I think you're falling behind, yeah? What are we doing? Okay. So here we're doing, this is my next book. The next book is How to Make a 5. Why are we learning how to make a 5? We're learning how to make a 5 because that's one of the pillars in Abacus World. The reason why we need to learn how to make a 5 is because we need to utilize this top bead. This top bead is going to be our constant. No, she owns that many. Oh. So the first question we're going to do, and I know you guys know this, but this is the question that we're going to work on. We're going to work on 4 plus 4. 4 plus 4 is not what we're going to memorize. What we're going to do is we're going to understand how to utilize the abacus. We're going to utilize the abacus to understand it. So why are we going to add the 4? We're going to add the 4 because that's what the question is. When we add another 4, we have no more room. We have no more beads. Guess what? The beads are going to be in here somewhere. What does that mean? So I have 4 on the abacus, right? 1, 2, 3, 4. But guess what? Because I have no more room for the abacus, for the beads, I can utilize a 5. But because I utilize the 5, I'm going to expect change back. So I need to take away the 1. So my final answer is 8. 5, 6, 7, 8. I could do it again on the abacus. Add the 5, take away the 1. And my final answer is 8. 5, 6, 7, 8. Japan math is making me understand more than the math here. I do not know how, but yeah. Yeah, you know why? Because it is visual. Because you can see it and you know what you're doing. That's what it is. And that's why I really stress and emphasize the fact of reading the abacus. I don't know. This is so much more difficult than the way I learned back in the 70s. It's not difficult, it is unfamiliar. Because back in the day in the 70s, we had to memorize. You had to memorize that 4 plus 4, right? You had to memorize that. What is 4 plus 4? You can count up what 4 plus 4 is, and that's what mainstream math does. So mainstream math did, I have 4 pens here, and I have another 4 pens here. What do? You have to count 5, 6, 7, 8. Which is fine. You could do that. You could count up. Not a problem. But we're not here to judge. We're here to be familiar with something different. Please, Juju, keep your mind open. I just understood that if you had 4 and you added 4, that was memorizing. That's memorizing. Yeah. Here is memory, not visual. Yeah, that's memorizing. If you just knew it, that's memorizing. It's so much easier and needs to be taught in school. Thank you. Visualization helps. Yes. Juju, we're not here to judge. I'm not judging. But that's what it is. And a lot of the children, if that was the case, then we wouldn't be having problems in math because the kids can't memorize. We are just now become illiterate. Oh my God, that was the other thing that I saw. I saw this one movie. Remember I Am Bored Again? I saw this one movie. It was called The Truth About Reading. And there was this English professor and he was illiterate. He was able to get a master's degree and he was illiterate. And I'm like, how is that even possible? It was because he memorized and he didn't understand how to read the words. Hello, Rob! Welcome! Right? Yeah, it was called The truth about reading. And there was like these millionaires and CFOs or CEOs or whatever, and they were illiterate. I'm like, how is that even possible? They're illiterate, but it happens. And they were able to finagle their way through. And I'm like, this is amazing. And so what I want to do is I want to show how it's easier, not easier, but a different way. So please, Juju, keep your mind open for something different.
Now open your mind to me, please. Open your mind.
I'm not memorizing the abacus. I'm seeing my numbers. So, Good Will Hunting. Oh, Good Will Hunting. Yeah, I just saw that one too. And I was like, oh, I remember. Okay, so they didn't receive phonics. Yeah. Or they bypassed it, which was really crazy. Like, how is that even possible? I don't know. I don't know how it's possible that they bypassed phonics because we kept talking about it. But it is what it is. It was just very interesting. So, MG, I'm not here to judge. If you think you're illiterate, then that is on you. I'm not here to judge. I'm just here to explain I'm just here to abacify the world. I would like to show what the abacus is to the matrix. Welcome, everybody.
Welcome to the real world.
So, what are we doing? And this is interesting. Thank you. So what are we doing? So we understand how to make a 4. When we make a 4, what we're going to do is we're going to understand that if we don't have enough beads, we need to utilize the 5. So we have 3 on the abacus, right? 1, 2, 3. And I want to add 4. But to add the 4, what do? I have 5 columns. I have 5, but I can't break it. Because I can't break it, I need to have an exchange. I'm going to take away the 1. So my final answer is 7. 5, 6, 7. I bought 2 books. Yes, I can't wait. Oh, hey, yes, I sent it out this morning. I'm excited for you to have it. I love learning so many things. Yeah, Abacify. Yes, thank you. Abacify. Yes. Angel, do you always go in a room and just yell out 6, 7? No, it's not 6, 7. It's 7. 5 plus 2 is 7. And I can do it again on the abacus. I can add the 5. But I have to take away the 1. Why? Because we have to subtract to add.
If you're going hard enough left, you'll find yourself turning right.
Oh, right. That makes perfect sense. Turn right to go left.
So if we look at it again, we have 3 on the abacus. I have 3 on the abacus. Here's my little bricks. Oh, there, we can't see that. So we have my little bricks, right? I want to add 4. No, I want to add 4. Yeah, I want to add 4. But guess what? Inside here, there's 4 cubes. 1, 2, 3, 4. I need to remove this 1 cube that's here. But I can't do it because it's part of a package. It's part of this whole thing. And it's difficult to break off. So what do is I take away the loose column, the loose cube that's out here. So I'm going to take it out. So if I add it, then there we go. We have 7. 5, 6, 7. I can do it again on the abacus. I can add the 5 and take away the 1. Oh, yeah. Sorry. There we go. Thank you, Angel. Is there a way to show 0 on the... Yes, 0 looks like that. That's what 0 looks like. Okay. Thank you, Matter in Space. Thank you so much for joining. I hope to see you in my next live. Thank you, Nazar. Thank you for checking in. This is actually how I do math in my head. That's fantastic. That is fantastic. So when we're looking, right, we're going to understand that if I have 4 on the abacus, 1, 2, 3, 4, we could do it again. I want to add, I need to add 4, but because I don't have any more loose beads to add the 4, I have to use this 5. Adding the 5 means what? There's too much. So if I add the 5, that's too much, right? I have 9, right? 5, 6, 7, 8, 9. So if I'm only going to use these 4 cubes, I need to remove at least 1. This is the one I will remove. So if I take it away, then that can be replaced. And now we have 8. I wish they taught. Yes. So much. Okay. So anything above the 5, you have to subtract. If you have no more 6. Yes, exactly, Giorgio. Yes, exactly. So when you're looking, anything above 4. Because if you do 2 plus 2, do you have enough? Yes, you have enough. That's not a problem, right? No, that's a really valid question. The thing is when you need to have more than 4. So if I have 3 on the abacus, I want to add 4, right? That's this question. Well, guess what? What if I had 3 on the abacus? If I had 3 on the abacus, and I want to add 3, well, guess what? I have 3 on the abacus, 1, 2, 3, right? I'm using these 3 right here, right? But guess what? I need to remove these 2 beads. To remove these 2 beads, I can't from this package. I got to take it away from here. 1, 2. So then I have 6. 5, 6. Thank you, Landry. Yes, good. What if I count? What if my head counts 4, 5, 6? Whoa. 4 plus the blue bead, 5, 6, 7, 8. You could count up, but we don't do that in abacus. If that makes sense, Raphael. We don't count up. That's what the Chinese abacus does. You count up. But Japanese abacus, there's formulas. So the formulas, because we want to scale it, right? So what happens is we know how to do this. I mean, you could count up. It is up to you. It's up to you if you want to count up. So if I have my question, right? 100. So it all depends, right? 1,357. I want to add 2,431. 2,000, is there enough? Yes, add 2. I want to add the 4. To add the 4, guess what? You could count up. You could count up. Or I just have a shortcut, plus the 5 minus the 1. And then we add the 3, 1, 2, 3, and then we add the 1. So I think what it is you could count up, but we're looking at shortcuts. So what's my final answer? What is my answer? Yes, Landry. Yes, the blue beads is 5. Yes, exactly. Shortcuts is better. I think so. I think the shortcuts are better. So it is different because that's what mainstream math does. Mainstream math counts up. But in Abacus, we know because we're restricted on our column, we know that we can utilize a formula. Thank you. It is 3,788. Well done. That's what it is. 3,788. Thank you. Here comes the sun. Thank you, Doug. Thank you, Salt. Thank you, Reese. I don't know what that means. Yeah. So what are we doing? Yeah, I think it's the short. I think that's what it'd be called. It'd be considered a shortcut, because we understand that this would be the constant, right? And it's the same thing. If you know how to add, you'll know how to subtract. So you'll know that I added 4 to take away 4. All I got to do is take away the 5 plus the 1, which is opposite of plus the 5 minus the 1. Thank you, Sinister. Thank you for sharing my live, right? And so what are we doing? We're understanding concepts. These are simple concepts, right? So skipping the first puts it in the... knowing that this is a marker, this is my ones marker, puts me in the ones place. That's what that means. So when we're looking, Yezi, this is the ones, tens, hundreds, thousands, 10,000s. Over here is my decimals. We have our tenths, and then we have our hundredths. Does that make sense? So we can have 200, so 3,788. That's what that is. Yeah, no, thank you. No, that means you're actively learning, right? Because you're trying to understand the things that are coming through here. And so that's the difference, is you can either passively watch or you can actively learn. And I'd like it if you can actively learn. So I appreciate the comment. I appreciate the comments. Yes. So on a bigger abacus than the numbers, no decimal, can you reimagine the place? Yes, Landry. So if I had a 13 column abacus, it actually doesn't matter where you put your place value. Right? You could put your place value here, but then you notice that there are groupings. So if this is my ones, this is my thousands, and then I have my millions. Right? Or if I choose this to be my ones, I have my thousands, millions, and then billions. And then guess what? If I have my ones over here, this would be my ones, thousands, millions, billions, and then trillions. So yeah, it would be reimagined. So it just matters, where do you call the home? Where do you call ones places? And that is what signifies what comes a decimal and what becomes a whole number. Yep. Right? And so these decimals, even though you cannot move it, but the concept of, or the perception of the numbers is up to you. And every number is 9. The highest number you can have is 9. Why? Because 10 is 2 digits, right? 10 is a 1 and a 0. So 10 is a 2-digit number. 10 is a 0 and a 1, right? So we count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Notice the 1 and a 0, and then we count it again, right? Then we have 2 and a 0, and we count it again, and then 3 and a 0. But yes, that's a very good question. Thank you, Landry. Make sense? Are we all right with that? So, stop swearing. You don't need to swear in this room. If you think you are, then you are. I didn't judge. You have come into my room and swore. You don't need to swear. Okay? So when we're looking, we have our ones, our tens, our hundreds, our thousands, and our 10,000s. Thank you, Yezi. Yeah, right? Okay, so now what are we going to do? Well, guess what? We're going to do, we'll do one more, which is the minus. We're going to do the minus. Now, what happens is, if you know how to add, you will know how to subtract. Okay, what does that mean? Well, we learned, what did we learn? We learned, I have too much stuff. We learned that we can add the 5, right? To add the 4 is equal to what? Plus the 4 is equal to plus the 5 minus the 1. When we're looking, it's minus the 4 is equal to minus the 5 plus the 1. Guess what? Now you're going to start seeing number patterns. You're going to start seeing a pattern. Why? Because on the abacus, you're going to see that if I have 4, I want to add the 4. We know we want to add the 5 minus the 1. That's what we're going to do. Then if we take away, when we take away, we do the same thing. We minus the 5 plus the 1. Minus the 5 plus the 1. Do you see how there's a number pattern? If you know how to add, you know how to subtract. That's what we're doing. Does that make sense? So we could do it again with the 3. We add the 3. We take away the 3. 8. No, we can't take away the 3 because we have 3. 1, 2, 3. That's what we're going to do. We're going to do 7, right? If we do 7 minus 3. 7 minus 3. We're going to do minus the 5 plus the 2. I know, right? I know.
Oh, I can see everything.
Yeah, exactly, Giorgio. You see those kids doing this? It's because they're doing this. They understand the concepts, they're doing the shortcuts, and then you just do this, and they know what they're doing. So what they do is they imagine the abacus. If you notice, I don't do any calculations on the abacus. In the abacus just shows you the number. That's all it does. It just shows you the number. What you're doing in your brain is you're doing the calculations. So it's a different way of thinking. It's a different way of thinking. It is different than mainstream math. That's yeah. Okay. I need to block Michael. I'm just learning that. Michael's just being very conceited. Okay, this is, yeah, I'm not here to judge, but I don't need you to hear all of that. I don't need to hear all of that. All right, so yeah, right? So that's what it is. And so when you're looking, Abacus does the formulas you do the formulas in your brain. I write it out because I'm teaching you guys. But if you start going into it and understanding how to do this concept, right? Thank you. I appreciate that. Yeah, Yezi. I had to block him. He was getting too like judgy. I don't need people to be judgy. This is a safe space. If you don't understand, that's great. If you do understand, that's great too. I'm perfectly fine with whatever you want. I'm not here to judge. I'm just here to teach. And if you like it, that's great. If you don't, then you know what I mean? Like they can move on. I'm not here to be hurt. Thanks for spreading the knowledge. Thank you, Juan. I am here to spread the good word of the abacus. I got jokes. I got jokes. Thank you, everybody, for joining. Thank you so much for joining. Please keep your mind open for something different. It is not new. It is different.
Now open your mind to me, please. Open your mind.
Abacus has spoken. Yes, I gotta get that one. I was gonna get that one. I have spoken. I was gonna get that one. I haven't done it yet.
This is the way.
This is the way. This is the way.
Thank you. Hey, SoCal, you're back. PB SoCal, welcome back. It's been a little bit. I'm so happy you're here. How often do I teach? Every day. This is a craft. This is a learning tool. It's interesting that it is an art form, but it's an art form that is still utilized for the young kids and to keep your brain active. And you want to avoid, which is a new one that I was thinking about. Somebody has said it in the morning. Avoid brain rot. So we are here to stop brain rotting. Respect the abacus. So I'm happy to be here. Oh yeah, thank you. I'm so happy you're here. Thank you. Okay, so we're going to continue. When you look, right, you're going to understand that if you know how to add, you know how to subtract. So now, okay, here is a poll. Are we ready for the next one, or do we want to go into something? Do we want to go into multiplication? Is there? Oh, yeah, there we go. There's a poll. I've done a poll. This is my new name. Landry, that's funny. I'm going to buy an abacus. There's a poll. If you go to I don't know, there's a little arrow somewhere. I don't know how to find it. Please answer the poll and we will figure that out. So, I have a poll. Where is the poll? I don't know where the poll is. There's supposed to be a poll here somewhere. If you can click on the poll. I don't know. I can't figure it out. Maybe I don't have it. Oh, there it is. Answer the poll. I'm trying to be hip. I'm trying to understand Abic. I'm trying to understand TikTok. I did my first battle and that was kind of crazy. Okay, so yes, thank you. It's the top left and yes, clipboard. I wish my country taught this in the schools. This is awesome. You know, I don't know where you are, but it's very big in everywhere else except for America. I don't see it. Yeah, right here. Oh, you can't see it. Right there, there's a... Click on that. Oh. If you click on that, there's a poll. Yeah, I just figured out what I can say now. There we go. There we go. Hello, everybody. El Salvador. Hey, that's really cool. The clipboard with the timer. Yes, thank you, Rafael. You know, I wonder if it's there. I know, you know what? I take that back. I know somebody, well, that's El Salvador. So I know somebody from Brazil was mentioning that they were talking about the abacus, but their abacus was 10 beads across. I had one growing up. That's great. I remember trying to learn in Peru so I was wondering, what are your thoughts about Singapore math system? I don't have any thoughts about the Singapore math system. It is different than abacus. There's more visuals, but it's more visuals, but I have no opinion on it. You taught me in like 20 minutes. Yeah, I love multiplying. Oh, great. In the grand scheme of things, abacus would start first, then go to Singapore math. So it's not a comparison. It's not only abacus and only Singapore math. It is abacus is like level 1, and then Singapore math would be level 2, and then algebra would be like level 3, and then calculus would be like level 500 CC8. You know what I mean? And so, yeah, American math system is a brute force in the calculator. Exactly. And so, and that's the other thing. Like, when we start doing multiplication, also, just so you know, oh, here we go. I guess we're going to do multiplication. You guys are funny. We're going to do multiplication. Okay, so in multiplication on the abacus is really interesting. The reason why is because we actually know what our numbers are. I still have the slide rule somewhere. There's another person like, I need to teach slide rule. I'm like, dude, I don't know how to do the slide rule. That was actually before my time. The slide rule was before my time. Okay, so we will do. It's my cousin that says so too. Yeah, it's very interesting on like how mainstream math does it, and for those people that can pick it up, it's great, right? But for a lot of us average people, like I'm really average. For us average people, it was very hard to do math. Like it would have been a lot easier if I could visually see my numbers, which is crazy. I might like math if I had learned this. Yeah, I think so too. I think I would have done a lot more if I was able to visualize my numbers. And maybe that's why I'm such a visual person. I don't know. I do like that. Thank you for that. My kids in school are transitioning from Common Core to the Math Core system. I hear good things in it. Good luck. Yeah. Yeah. 4. Oh yeah. I have a friend that does it, but I have no opinion on it because I didn't go that, because I'm not here to compare Abacus to Singapore math. I'm here to compare Abacus to mainstream math. So, hello Jordan. Good. I've always hated math until pre-calc and calculus. Oh hey, changed my life. I've always struggled with math. I ended up not liking it, but you gave me oh good. I'm so happy. Very human. Okay, we're gonna do multiplication. Multiplication on the abacus is very interesting. What we do is we do distributive property. Distributive property means what? We're going to take our number and we're going to go one number at a time. We take this number, and we multiply it. That's what we're going to do. But before we do that, we need to understand and look at our question. Our question looks like it's 3 digits. 1, 2, 3. Because I know my number is 3-digit, guess what? My answer is going to be somewhere in the 3-digit. So now what did we do is we critically thought, we were analyzing our answers. We know we're going to be somewhere in the hundreds. We're not just going to blindly like brute force it, right? We're not going to brute force our answer. We're going to say, oh, we know that we're going to be in the hundreds. So I'm going to count 1, 2, 3. So now what I'm going to do is now I'm going to divide it. I'm going to times it. I'm going to have 5 times 8 is equal to 40. I add the 4, I have the 0. Notice I have 400. Why is it 400? Because the abacus holds my place value. When I look, I'm actually doing, excuse me, 50 times 80. If you notice, this is what they do in mainstream math. They do this because they're still writing it on paper. On the abacus, we don't need to write it on paper, but in the mainstream, we have to write it on paper. We have to make sure we remember our place values. So it is actually 400, which is what we have here, 400. And then our final one is 6 times 8 is equal to 48. Thank you, it's you. So we have 4 and then add the 8. And so my final answer is 448. That's so interesting, it's you. That's very interesting. My son, one of my kids is like, you should do a marathon. I'm like, whew, I don't know. I don't know. But if you think it's relaxing, then I can continue on. That's very reassuring. Thank you so much for letting me know. Right? This is cool. It makes perfect sense. Yeah, it makes really good sense. But see, that's the thing, right? Because in mainstream math, what do? They do 56 and then we do 8, right? And then you do 8 and then you do 4 and then you have to do 4, 8. Oh, sorry, 4 and 8. But it's different because you start from the ones place. But in abacus, we don't do it we do it the other way. Right? Does that make sense? So we could do another one. Let's do another one. So obviously, right, these are very simple numbers. These are very simple numbers. I hear the word math and I get an instant headache. You've got over, oh, hey, polishing their math skills. I know, right? We're just doing basic math. We're just doing adding, subtracting, multiplying, and dividing. Hello, man, cover hole. Thank you so much for the follow. That's a funny username. This is the best. This is the best. When I can see their usernames, it's so funny. They're so funny. So, yeah, like I am bored again. It's so funny to say the screen name because people are like, are you talking or are you saying somebody's name? Like there's another person I saw their username was no. And they're like, what are you trying to say? But the person's name no knew that I was talking about no. But it was just funny. Anyways, so what's our next? We could do another one. Let's do another one. And it's very simple. This is very simple math. I understand it's simple math. I'm teaching you is the concept. And we can do it, right? We could do it again. So we have 28 times 3. Again, what are we going to do? We're going to know that it's going to be somewhere in the 3 digits. We have 1, 2, 3. Why? Because we have 1, 2, 3. And then what are we going to do? We're going to do 3 times 2 is equal to 6. Well, guess what? This is where it becomes a little different. Why? Because we need to convert our number into a 2-digit number. If I can find my... here it is. Right? We need to convert it to a 2-digit number. Why? Because it's a single digit. We need to push it over. We need to remember that there's a 0 here. It's not a foreign concept. Why? Because you can do it like we do it in the time. So 1103, right? Or if we did a 2-digit month, 2-digit day, 2-digit year, it is 050611. So it's the same thing with this. We have 0 6. So what does that mean? We have 1, 2, 3. 0, 6. The 0 pushes our number to the one over. And then I add my 6. So then our next one is 3 times 8 is equal to 24. Right? So add the 2, add the 4. So my final answer is, what's my final answer? Every teacher was like her. She seems so... Thank you, Carlos. I enjoy when people are having fun. Thank you, Raphael, right? 84. Thank you. Yes, thank you. Meant to say Saturn? No. Right? So it is not 314. No. It is 84. Because the top beat is a value of 5. The bottom beat is a value of 1. There's 3 of them. 1, 2, 3. Together, you get 8. 5 plus 3 is 8. And then we have 4. 1, 2, 3, 4. They're not separate, right? They're not separate. Meant to say Saturn, they're not separate. Does that make sense? So every column is always up to 9. This is one number, this is one number, this is one number. But that's very creative of you. Meant to say Saturn. 0 is in the hundreds place. Yes, you're right. 0 is in the hundreds place. So we have 80 and then 4. Yeah. It was very creative what you said, but I see what you've done. Yeah. 3, 1, 4. But yeah, what we're doing is when we're doing it, we do 1, 2, 3, 4, and then 5. The top beat is a value of 5. We have 6, 7, 8, 9. Every number is counted on one column. There is no duplicates like Sudoku. You can only have one number in every line, right? Just like that. So we have ones, tens, hundreds, thousands, 10,000s. So we have 9, 90, 900, 9,000, right? It works exactly the same. So every column can only have one number. There cannot be a duplicate in the same column. This is a column. So you do this. This is not duplicate. This is 22. And then we have 322 or 222. Yep. So we can talk about our place values. We have our ones, tens, hundreds, thousands, 10,000s. I usually do Sudoku before night. Yeah. You know what? And that's the thing. Abacus can also be very similar to Sudoku because it's like a puzzle. When we look at the numbers, it's like trying to figure out what the puzzle is. And that's what it is. Oh, I felt it like when you do long numbers, their own placement values and then crossover. Yeah, I understand. Just like the 10 bead one, right? 10 beads. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And then you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you were thinking, I'm assuming, right, that it looks like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you thought that they were, yeah. Yeah. I meant to say I get it. Oh, yeah. Cool. So the hundreds, tens, yeah. Not row, column. Every column, right? Column goes up and down. It's not row. Because this would be the row of fives. This is the row of ones, right? That's the row of ones. This is the row of twos. This is the row of threes. This is a row of fours, right? So it's not rows, it's columns. Every column is represented. So we have 1, 2, 3, 4, and then 5. Yeah. Good. Oh, meant to say, Saturn, my brain is itching to learn shortcuts and then try to do it in the air like those kids. Can we do another? Oh, multiplication? Yeah. So what is the difference between this one and the large abacus? When you say large abacus, are you talking about the 13 column abacus? The 13 abacus, the 13 column abacus just means that the size matters, right? That just means you just have more numbers. That's all it is. I came in here not understand and now I get it. Oh, good. Oh, good. Good. I'm happy you're not a troll. I cook trolls. There's this one troll that came in and the profile picture was fishing and the comment was, why don't you use a calculator? And I'm like, what? Why are you fishing? Why don't you just go to the supermarket? So anyways, I thought the columns were longer for some reason. Yeah, no. The columns are the same. It just matters on how many you are. So the digits, right? So we have our hundreds. So this is 13 digits. That's all it is. Yeah. Same. You're a great. Oh, thank you. Thank you, Yezi. Right, Salt? Why do you come when you're a troll? Make your profile picture not anything recognizable. I used to see these things on TV and I've always wanted to use one. Oh yeah. And that's what it is. And so you'll notice it's quite everywhere and you're going to start seeing it in movies. So it's in Madagascar, Penguins of Madagascar. It's in Fairy Mary, Tinkerbell. It's in Wonka. There's a character, his name is Abacus Crunch. It's in other things. Trolls help you push out your page and boosting. Yeah, when they make comments, yeah. If I'm not tired, I will cook some trolls. I feel like it was in Polly. Yes, all of those great movies. Yes. I don't know about Polly. I'll have to take a look. There's another one, Soul. It was in Seoul. And then Mulan, which kind of makes sense because Mulan is Chinese. But it was interesting. The Chinese ancestors was using a Japanese abacus, not a Chinese abacus. So that was an interesting thing. Oh, yeah. Thank you, everybody. It's even an anime. Yeah, well, anime is Japanese. So I didn't think it was That was kind of like a common thing, and they were doing it proper. So there was one person. What was it? There was I think it was there was one anime that I was watching, and there was this old man doing the abacus, and it was correct because it's Japanese made. Yeah. So, are there any downsides to teaching this to your kids instead of the traditional math and taught in school? The only downside is the kids will not want to show their work. Yeah. Hello, Liz. I'm an anime. Oh, do you? Oh, I love AOT. I cannot get enough of it. I've watched it like 4 times already. I love AOT. Oh, it's so amazing. Hold on, Liz. So we're gonna count. Okay, Doug. What's the difference between the Japanese and the other abacus? Well, there is a 10-beat abacus. A 10-beat abacus is straight across, and what they do is they do 1-to-1s. Right? So they do 1, 2, 3, 4, 5, 6, 7, 8, 9, and then there's 10. Whereas on the Japanese abacus, it is, I know, right? AOT. Scared to finish the 4th one of AOT. Oh my god, it was so good. It was so good. Okay, Doug, if you're an anime chick, good, Giorgio. If you're an anime chick and I like AOT, what is my next anime that I should watch? I love AOT. I had to buy this whole series. Oh my god, it was so good. My kid, he introduced me to AOT, and it was like kind of difficult because I'm like, what's going on? What's going on? What's going on? And then finally it picked up. I'm like, oh my god, this is crazy. Woo! Right? Ah, oh, so good. So good. You should watch Hunter x Hunter. Really? Are you sure? I will have to ask. If you like AOT, really? Okay. That's a good show too. Okay, I'm going to take a look. Oh, Doug, you're missing out. Oh my god. You gotta watch AOT. You gotta watch Attack on Titan. It's so good. I watched it 7 times and I love. Okay? Okay, Jacob, I will. Full Metal Alchemist might be the next one for you. Okay. Demon Slayer? I don't know about Demon Slayer. I tried that one. That wasn't so good. I'm sorry, Liz. So we have 1, 2, 3, 4, and then 5. That's a 5. AOT is Attack on Titan. We're just talking about anime now. So Liz, this is what we're doing. We're learning how to read the abacus. We have 1. We have 1. So just like Roman numerals, remember Roman numerals? We have 1. We have 2, 1, 2. We have 3. That's 3. 1, 2, 3. We have 4. The value of 4, right? That's 4. It's just minus 1. But then 5. 5 is a V. 5, that's what 5 looks like. And then 6 is 5 plus 1. 5 plus 1. And then 7 is 5 plus 2. And then 8 is 5 plus 3. Does that make sense, Liz? And then it gets silly, but it's pretty good. I don't know about. I tried Demon Slayer, right? Demon Slayer is the one with the brother has a sister that turned into a vampire or something, and he tried to. I don't know. I couldn't do it. I love Demon Slayer, but S8 broke my heart. Yeah, I don't know. Jujutsu Kaisen. My kid likes Jujutsu Kaisen. Right? Yeah. My kid likes Jujutsu Kaisen. Maybe I'll watch Jujutsu Kaisen. But I'm going to make a note of the Hunter x Hunter. There was another one. Ludicrous? Lucius? Something. So, okay. So, thank you, Liz, for the follow. Has a lot of action, less important. Nah, I want the story to be important. Yeah. Okay. So then we have what? We're going to notice that we have our 1s, our 10s, our 100s, our 1000s, and our 10,000s. So, Kathy, number 8 is great. Really? Short anime. Oh, sorry. Lupin the Third? No, it wasn't Lupin. It was like Lucius or Luda something. That too. I don't know. Okay. Sorry, Diva from the... Okay. So, thank you everybody for the for the recommendation. Full Metal Alchemist Brotherhood. Okay, Chainsaw Man. Okay, I will keep a note of this. I will keep a note. I keep asking my kids, what's the next anime? So we have our ones. Liz, I hope you're still here. We have our ones, our tens, hundreds, thousands, 10,000s. So you notice that this is 9. 5 plus 4 is 9. Then 10 looks like this. This is 10. So we have 1, 10, 100, 1,000, and then 10,000. That's what that looks like. And then so if we look, we can actually have our numbers. Every column is a placeholder, right? Every column is a place value. If I have this as my ones place, I line it up, I could do 6, 5, 4, 3. Liz, are you still here? That was a tangent. Okay, so let's do it again. Let's scale it. So if we did 7,000, 73,000, 73,456, you can read it, right? So now if I do 20, 0.2, and 0.5. So we look, we have 10,000, right? 73,456 point. The decimal sits between our ones and our tenths, not as our place value. So this is why we get our decimals. I would recommend Forever and Beyond, Journey's End. If you haven't watched it already, absolute cinema. Oh, okay. Okay, Saturn. Okay. When I have time, I'll take a look. Hello, Tyler. Hello. So does that make sense, Liz? So when we're looking, if this is what we're doing, 555.555, right? That's what that would look like. 55,555.55. Back to math. Yes, back to math. And so we do 9, right? Every column is a 9. 99,999.99. There we go. So, for those of you that are interested for yourself, I do have an abacus for adults. And it's over here. That's what it is. For those of you that are interested, I also do have books for children. My books were meant for children. Hello, Bean. Hello, Bean. Yes, good. So when we're looking, so then you might be wondering that this is my ones place. This is why I have my ones. Now, what if I choose this one to be my ones place? Well, guess what? I can just move everything over like that. So it'd be 1, 2, 3, 4, and then 5, 6, 7, 8, 9, and then 10. 10 is a 1 and a 0. So then what happens? Well, now we can actually make a really, really small number. We can have 0.00001. Welcome everybody. Thank you so much for joining. My name is Lynette. Please keep your mind open for something different.
Now open your mind to me, please. Open your mind.
Okay, let's do that. So, thank you, Tyler. Okay, we're gonna do some adding. When we add, we're gonna do how to make a 10. How to make a 10 means what? I am visual. How to make a 10? We need to understand that we need to make a 10. How do you make a 10? We have 5 plus 5 is equal to 10. We need to know these pairs. 2 plus 8 is equal to 10. 3 plus 7 is equal to 10. 4 plus 6 is equal to 10. 1 plus 9 is equal to 10. We need to know these, right? Why? Because when we're looking like this number, I have 4 on the abacus. Let me do 4. 1, 2, 3, 4. Okay? I want to add an 8. Guess what? When I add an 8, I know I can actually make a 10. This is 5, 6, 7, 8. So what we're going to do is what? To add an 8, we need to make a 10. To do that, we have 2. So we know 8 plus 2 is equal to 10. There's an 8. I need to find my 2. My 2 is going to come from my 4. I'm going to take it away from the 4, like that. And I'm going to make a 10, like that. So that's what we do. We carry on. So my final answer is 12. What did we just do? We did a right to go left. We subtracted to add.
If you're going hard enough left, you'll find yourself turning right.
Oh, right. That makes perfect sense. Turn right to go left.
No, I don't know. I'm just missed somebody's comment. But yeah, does that make sense? So now, rage bait Randy, welcome. Stop swearing. You don't need to swear in this. Who invented this? I don't know. Some Mesopotamia? Please, rage bait Randy. We have children in the room. So please, do not swear. Oh, who is it? Yeah, I don't know who invented it. Some brilliant person. It's just like, who invented the decimal system? I don't know. I don't know who invented it. So, does that make sense, Tyler? So, when we're looking, we could do it again. We have 7. Notice, right? We go 7. So, we have 7. 1, 2, 3, 4, 5, 6, 7. Yeah? Right? Dewey. Dewey. The Dewey system. So, we have 7. I have 8. If I want to do 8, we have 8. 1, 2, 3. Okay, 5, 6, 7, 8. There's my 8, right? So, we have 7 on the abacus. We have 7 on the abacus, right? 7. We want to add 8. But notice with my 8, I can make a 10. I can make a 10. I have to make a 10 with an 8, I know I'm going to make a 2, right? So, what I'm going to do is I'm going to take away the 2 to make a 10. So, I have my answer. My answer is 15. I take away the 2 from the 7, and I add the 10. And there we go. Rage bait Randy. Rage bait Randy. Rage bait. You need a Randy. I think you need to go to sleep. I think you're tired because you're being very judgy. Very, very judgy. All right. That's all right. I blocked rage bait. All right, next. Okay, I'm upset because I got the end of the miss and more important about adding. Janice? He's rage baiting. Yeah, he's trying to rage bait, but it's not working. It's hard. It's hard. I think it's difficult for me to get mad now. I've had a lot of trolls. Janice, you ended up missing the important part of adding? No? We're still here. We're still here. So we have 8, right? We have 8 on the abacus. 8 on the abacus. We'll do 8. 5, 6, 7, 8. Right? And then we're gonna add another 8. We're not gonna memorize, right? We're not gonna memorize. We're gonna add another 8. To add another 8, we have this, right? What we want to do is we have these 2, and we know that when we want to add an 8, I can add a 2. But I got to get it from somewhere. I have to take it away from the previous 8. So I take it away from the previous 8 and I add it to my new 8, and it gives me a 10. Now I have a 10. I take away the 2 and I add the 10. So my final answer is 16. Just like how we have to subtract in order to add.
If you're going hard enough left, you'll find yourself turning right.
Oh, right. That makes perfect sense. Turn right to go left.
Okay, Raphael, I'll see you later. Have a good night, and I will see you in my next live. Janice, I'm bad at English, but good at math. Okay, good. How the heck do you work the abacus? I've never understood them. Rude people need to go if they don't have anything better. That's very true. That's very true. That is genuine. That makes sense to me. That generally makes sense to me. Yeah. So when we're doing it, what we do is we have this formula. The formula that we need to memorize is when I want to add the 10, I have to add the 10 minus the 2. Why? Because when we add the 10, it's too much. I passed multivariable calculus, and differential equation never learned how to use the abacus. Okay, that's fine. I'm not here to judge. You go right ahead, Joey. I don't know why you're here. Are you wanting to learn how to use the abacus? It is up to you. But we're not here to judge. There's no judging. Okay, great. Yeah, Tyler. So, Tyler, did that make sense? Right? You did it twice with the bricks now. Do it without the bricks. Okay, here we go. Hello, Liz. Okay. Have a good night, Liz. Thank you so much for your patience. Talking about anime. It clicked for me. Thank you so much. All right. So we're going to do, let's do a number. Let's do 9. Let's do 9, right? 9 plus, I'll write it out. So what do? We do 9 on the abacus. And then what do? We need to add the 8. To add the 8, we know plus the 8 is equal to plus the 10 minus the 2. So what do? We plus the 10 minus the 2. That's the formula that we need to memorize, right? Just like we had to memorize our formulas, plus 4 is equal to plus 5 minus 1, right? That's one formula. This is another formula. It's 2. Ah, my God, Helen, you need to go to bed. I will watch AOT. You're going to watch Attack on Titan? I think you can watch it on Netflix. I'm not sure. Good night, Giorgio. Good night. Okay. Yeah, I'm going to watch Hunter x Hunter. Okay. You guys are so funny. Did that make sense, Doug? So, Crunchyroll 2. Okay, I'll take a look at Crunchyroll. Subtract 2 from the ones. Yes, exactly. Subtract 2 from the ones column and then add in the tens column. So that's the formula. That's the formula. Minus the 10, plus the 10 minus the 2. We can do it again with the 9, right? We could do it again with the 9. Let me see. Let me get to this 9. There we go. So what do? So this one is available. It's this one over here. Okay, so what do? If we did 9 on the abacus, I want to add another 9. To add another 9, what do? All I got to do is minus the 1 plus the 10. And I would recommend when you start doing the abacus, I would recommend to say the formulas out loud. I would say the formulas out loud just to see what you're trying to do. Because if you don't talk about the formulas, then it kind of sits in your brain in a little bit, and then you might get a little bit muddled. So I would suggest, I still say it out loud. Even if you guys were not around, I would still say it out loud just to make sure I follow the directions. Because that's what this is following the directions. So then what are we going to do? We could do it again. But notice, when we do it, we want to go from top to bottom. So here's the next question. Let's do 9. When I put 9 on the abacus, I do not want to make 10 out of my 9. Because there's no number to make a 10 out of. But if I add the 5 is what I want to do to make a 10. I don't want to do the 10 at the 9. It always goes from the top down. Right? So we start with the 9 and we go down to the 5. The 5 is what we need to do. So when we add the 5, what do? We need to minus the 5 plus the 10. Top down. We're making 10 out of the 5, not the 9. Does that make sense? So don't go up and down. It goes from top down. The reason why is because when we do more numbers, we can't go up and down. We go 1 and we do a running total. We take the top, go to the second, go to the third. Okay? So when we're doing abacus, we make a running total. We don't go up and down. I know in mainstream math they go up and down because they want to make it easier. But the problem is when you start going up and down, you're going to start losing track of what number you've done. So always go from the top down, and using the abacus is like keeping a running total. That's what that is. It's a running total. How are we doing? Cool? So when we're looking, we can do it again. Well, let's do 4. Again, go from the top down. So we have 7 on the abacus. 7 on the abacus. I want to add 4. Well, guess what? When I add the 4, what is my formula? Plus the 4 is equal to plus the 6, plus 6 equals to 10. This is where I do my modification.
You need modification! Modify! Modify!
I'm going to isolate this 4. To isolate the 4, I do 4 is equal to 10 minus 6. Minus 6. So, minus the 6 plus the 10. So my answer is 11. We're not going top down. We're not going up and down. We're going top down. So we could do it again. We do 8 on the abacus. To add the 8, what do I do? To add the 4, what do I do? Plus the 4 is equal to plus the 10 minus the 6. So we plus the 10 and then take away the 6. So my final answer is 16. Yeah? I'm sorry, yes, thank you, Liz. Ha! It is 12. You're right. It's getting late for me. Okay, how are we doing? Okay? Make sense? All right. Yeah. Okay. So thank you everybody for joining. Thank you everybody for joining. Haha. Thank you. Thank you, very human, for the finger heart. Please keep your mind open for something different.
Now open your mind to me, please. Open your mind.
So let's do a little review. We know that this is 1. This is 2. Thank you for the follow. That was fun. Oh, good. Oh, good. And then we have 3. We have 4. And then this is 5. The top B will always be 5. We have 6, 7, 8, 9, and then 10. We have 11, 12, 13, 14, and then 15. 16, 17, 18, 19, 20. Right? Tyler, you still okay? So when we add, I got school tomorrow. This helps a lot. Really, Neo? Welcome. Welcome.
Welcome to the real world.
That was for Neo because Neo has a Neo name. I really like the Matrix. I love the Matrix. Yeah. And so when we're looking, I'm trying to introduce Abacus to the Matrix. Thank you for checking in. Hello, Jinx. Welcome back. Welcome back. We were doing some how to make a 10. And so again, there's this book. This book is about how to make a 10, and I have activities. The first thing to do is there's all these instructions on how to make a 10, and then you have activities, and here's color by number, and this is adding the 6. We have the spinning of the wheel, and then so forth. So then after that, what do we have? We have puzzles. We have puzzles. So you answer the question, and then you have to find the answer. There's a hidden word. After hidden word, there's more hidden words. I do have mazes. I have mazes here somewhere. I have a lot of puzzles. Puzzles and mazes. And so what it is that I solidify the concept of how to make a 10. And then we have mazes, and then I think that's it. Yep. And if you're ever curious, I do have answers in the back of the book. There we are. All right. How are we doing? Okay. Hello, Mexi. Hello, Mexi. How is it going? It's so funny that you always join. Does this abacus make sense to you yet? Or are you still confused? I know it takes a little bit of time. Great, I'm at work. Oh, interesting. You're at work. That's so late. That's crazy. You know, funny. If I think about it, I'm at work too. So you and I are both at work. Whew. Unless I'm used to it. Unless I can show myself sleeping and then you just watch me sleep. Which is crazy. I would be looking on TikTok and there's a few people that get like thousands of likes and they're just sleeping. And I'm like, how is that even possible? How is it possible that they're live streaming them sleeping? I don't get it. I don't get how they do that. So that is about adding of the 10. How are we doing, Tyler? Do you want to do some more? We can do... Here we go. So we have 18 on the abacus, right? We have 18 on the abacus. I want to add 7. To add the 7, what do? I have to plus the 10 minus the 3. And that's what I wrote up here. Plus the 10 minus the 3. My final answer is 25. They stream... excuse me. They live stream because they are in the East Coast, 3 hours ahead. Yeah, I guess so. But they're sleeping. That's the crazy thing. It's crazy. I'm PST. So am I. Welcome. For those of you that are interested, please keep your mind open for something different.
Now open your mind to me, please. Open your mind.
Would you say that this improves math skills even without the abacus? I think so. Because why? Because it's a different way of thinking. You don't necessarily need the abacus. It's just a different way of thinking. But I would recommend the abacus just so if you want it to be visual. But you don't have to have an abacus. The methodology is really quite interesting. Using the formulas. You want to show division? Yeah, I can show division. I have some division. Okay. Yeah. I count with my head. Yeah, you can count with your head too. That's not a problem. But if you want to do the abacus way, it's a different method altogether. The method is just different. What am I doing? I am... Excuse me. All right, there we go. Thank you for the follow. ACBB. Okay. So we have... I know this is easy. We can do it in our head. But we're going to start with this. So in abacus world, no. So we need to know yawning is contagious. Yeah, I think this will be my last one. I can't handle it anymore. It was too much excitement with anime. We have our dividend and we have our divisor, right? We have our dividend and our divisor. When we look at it, we need to know where to put our number. How we figure out, just like in multiplication, we added the digits. Now what we need to do is we need to subtract the digits. We have 2 digits in our dividend minus 1 digit in our divisor. So where we're going to put our answer, our quotient, is going to be in the ones place. Ones is right here. So my quotient is going to be over here. My dividend will be here, 6 and then 4. This is a placeholder. This is not 64, right? This is just a placeholder because we're going to actually start doing our division. We're actually going to do our subtraction on this number. So I'm going to hide the abacus. I'm going to hide the question, and we need to know that this is 2. So when we look, we have 2 times what is equal to 6. Because you could do this, you need to skip this column and go over here. So 2 times what is equal to 6? 3. Thank you, Mexi. So we have the 3, we had the 6, right? So we add 3 to the abacus, and we take away 6. 5, 6. And then our next number is here. So because our dividend is over here, we're going to put our answer here, our quotient. So the question is what? 2 times what is equal to 4? Well, if you can take away the 4, then you got to skip. If you can multiply to 4, you need to skip this column and go over here. So the question is 2 times 2 is equal to 4. Thank you, Karina. So we add the 2 and then take away the 4. So my final answer is 32. That's what the answer is. So we could put 32. Thank you, Mexi. I think I could pull a muscle.
I can see everything.
Does that make sense? So we have to take it slow. We need to just understand our multiplication fact. Thank you, Mexi. Yes, good. I'm happy you did it in your head. So when we're looking, we do the multiplication. I see, it's good to know. It's a little different, right? Because what we do is we separate the two. We don't say how many times 2 can go into 64. So what I did is I broke it up. Just like we do in multiplication, we break it up. We only look at the one column at a time. We did the 6 first, and then we did the 4. That's what we did. But in mainstream, what do? You have to divide 2 into 64. So you have to go what? I know 2 times 30 is equal to 60. Okay, I need to do one more. 2 times 31 is equal to 62. 2 times 32 is equal to 64. Yeah, it does take a little bit. The colors are throwing me off. I like they should have value. No. They don't have values. The only value they have is 1. You might need to change it to a single colored abacus if the colors are too much for you. So yeah, Doug, does that make sense? When we are looking at it, we don't need to take the number as a whole. We need to break it up. We need to break it up like this, like this, like this, right? Yeah. Yeah, sometimes the colors can get overwhelming, but that's the way it is. You could get a smaller abacus, but I don't sell it. All right. Thank you, Spicy. Right? So, I mean, we could do... And that's it. It's just like how we do multiplication. So, just like how we do multiplication, we did 32 times that by 2. What do? We do 2 times 3, and then 3 times 2 times 2. Columns. So every column is a place value, and every place value, hold on. There we go. So we have our ones. We have our ones, our tens. That's the tens. This is the hundreds. This is the thousands, and this is the 10,000s. Each column represents the place value. Yes. When you divide, but has a decimal, that's fine. Decimal sits right here. Right? Just like our tens and the hundreds. Oh, thank you, Spicy, for the gifts. I feel like... Okay, wait. Divide. Right. So, if I choose this one to be my ones place, then I move everything over, and I can do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's it. So after that, we have 11, 12, 13, 14, 15, 16, 17, 18, 19, and then 20. Okay. Thank you so much for liking the live. All right. I'm gonna head out. I'm getting really tired. I can't do it. All right. So for those of you that are interested, thank you so much for following. Thank you so much for following. And I'll see you all in my next live. Thank you. Thank you, Spicy. Hopefully I'll see you in my next live and we can start from the beginning. It was great. Oh, good. Oh, good. Happy. Happy. Good night. Good night. Good night, Virgo. I fell asleep. Yeah, I'm about to fall asleep too. I don't know how some people do it in the middle of the night and they're just like going. Yeah, not a problem, Virgo. Not a problem. Thank you so much for the conversation. It was fun. Thank you so much. It was a great conversation. Okay, so have a good night and I will see you guys all in my next live. Toodaloo, kangaroos.